Hi guys, today we're going to be looking at a question on redox reactions. Corrosion is a redox reaction that takes place in the presence of oxygen and water. Rusting is the corrosion of iron leading to the formation of 3 ions. Question 8.1.1. Define oxidation in terms of electron transfer. So, in redox reactions, we know that when an object is oxidized or goes through oxidation, it loses electrons. Therefore, oxidation is the loss of electrons. A cleaned copper rod and a cleaned iron nail are placed in a beaker containing water at 25 degrees Celsius as shown below. After a while, it was observed that the nail was coated with rust. The copper rod showed no visible signs of corrosion. Question 8.1.2. Write down the half reaction for the iron nail. As they have said, the rusting or corrosion of iron when iron leads to the formation of iron 3 ions. So since we have an iron nail and it forms iron 3 ions, it therefore loses electrons. Therefore, if we look at our redox reaction table, which should be at the back of your paper with the formula sheet, we see that Fe forms Fe3+ and 3 electrons. Question 8.1.3. Does iron act as a reducing agent or an oxidizing agent in the beaker? So, as we know, the iron nail was therefore oxidized. And when a substance is oxidized, it means it acts as the opposite agent. So, the iron acts as a reducing agent. Question 8.1.4. Explain the above observation by referring to the table of standard reduction potentials. In the table that you should have, along with the formula sheet, you can see that iron is a stronger reducing agent than copper is, according to how high or how low it is on the table. Therefore, since iron is a stronger reducing agent, it will be oxidized, forming iron 3+. To prevent rusting of an underground iron pipe, the pipe is connected to a metal Q that corrodes easily. Question 8.1.5. You are given 2 metals, zinc and copper, to use as metal Q. Which metal would be more suitable? Give a reason for your answer. As we know from this scenario above, iron is a stronger reducing agent than copper. Therefore, it will be oxidized. However, if we look at our standard table of reduction potentials, we can see that zinc is a stronger reducing agent than iron. Therefore, it would be more likely to be oxidized. So, if we want to prevent rusting of the iron pipe, we would therefore use iron as the metal, as it would oxidize instead of the iron pipe. I'm going to do the last question on a new page so it's easier to see. Question 8.2. A galvanic cell is constructed using a Fe3+ half cell and a Cu2+ half cell. Question 8.2.1. Write down the overall net cell reaction that takes place when the cell is functioning. So our net cell reaction would be, we would start with the Cu2+ ions and the Fe as it is, not the ion, as Fe is a stronger reducing agent than Cu. Therefore, it will lose electrons due to it being oxidized. So we would have Cu2+ plus Fe forms Cu plus Fe3+. However, if we write it like this, the equation is not balanced. Therefore, in order to balance the equation, as we have 3 Fe ions here and 2 over here, we put a 3 here to make it 3 copper 2 ions, and we also want 3 copper atoms formed. And then, to balance out the Fe3 ions, we put a 2 over here, and to balance it, we need a 2 over here too. So this would be the balanced equation and the overall net cell reaction that takes place. Question 8.2.2. Calculate the cell potential of the cell under standard conditions. So, under standard conditions, we can break up the 2 equations and we can say we have Cu2+ plus the 2 electrons as Cu2+ is reduced and we get Cu. And if we look at our redox table, we would have this to have the energy 0.34 volts. We then have Fe that goes to Fe3 plus 3 electrons. And this has the cell potential 0.06 volts. And if we add these together, we get the total cell potential to be 0.34 plus 0.06, and we get 0.40 volts. And that's all for this video. Thank you.